Hi, good morning. Today we are going to discuss about the corner of map minimization techniques. Under the unit minimization techniques and logic gates in that subject, digital principles and computer organization. In previous video, we have discussed about what is logic gates, what are the different logic gates available, then what are the laws that are used it for minimizing the terms, minimization techniques, what are the laws to be used. These are discussed in previous videos. Now we are going to discuss about K-map, that means the Karnaugh map minimization technique. Why Karnaugh minimization? K-map simplification technique is simpler and less error prone compared to the method of solving the logical expression using Boolean laws. Its main purpose is to simplify Boolean algebraic expressions. What is Karnaugh? Karnaugh map is also known as K-map. K-map was introduced by Dr. Maurice Karnaugh in the year 1953. Karnaugh map is a pictorial method of grouping together expression with common factors and then eliminating the unwanted variables. Karnaugh map uses the following rules for the simplification of expressions by grouping together adjacent cells containing ones. Group may not include any cell containing a zero. For example, in the given diagram, that we should not group either 0 or 1. We should group either 0 0 or 1 1. The same, we should group only 0 1 1 components to be grouped together. So we should not you group 0 and 1. Then groups may be horizontal or vertical but not diagonal. It may be either horizontal or vertical grouping, that we cannot use diagonally group. We cannot use grouping together diagonally. That's a wrong one. We have to group either horizontal or in vertical position. Group must contain 1, 2, 4, 8 or in general 2 power n cells. If n equal to 1, a group will contain 2 ones, since 2 power 1 equal to 2. If n equal to 2, a group will contain 4 ones, since 2 power 2 equal to 4. Here we are grouping only two numbers. Here we are grouping only 4. We are grouping must contain in a even format. We cannot group three in odd format. We cannot odd numbers we cannot group together. We can group only the even numbers, like it should contain either two ones or four ones or six ones. This to be grouped together, not even number count we cannot group together. Each group should be as large as possible. That group should be as much as large. Then for simpler grouping, that is not good. It should be large as much as possible. Then each cell containing a one must be at least in at least one group. There should be at least one group. Then groups may overlap, that once two ones can overlap with other groups, but we cannot group individual functions. Groups may wrap around the table. The leftmost cell in a row may be grouped with the rightmost cell, and the top cell in a column may be grouped with the bottom cell. This can be wrapped for grouping. Then there should be as few groups as possible, as long as this does not contradict any of the previous rules. There should be only few groups. We should make only a few groups as possible, so that it should not be contradict for previous rules, any of the rules. For there, it should follow some rules. For K-map, there should be no zeros allowed. There will be no diagonals. Only power of 2 number of cells in each groups. Group should be as large as possible. Everyone must be in at least one group. At least one group. There should be at least one. Overlapping is allowed. Wrapping around the table is allowed. Fewest number of groups must be as low as possible. Then there we are having a different variables, two variable, three variable, four variables and five variable functions we are having. Then number of cells in two variables K map is 4. Since the number of variable is 2, there is only one possibility of grouping 4 adjacent minterms. The possible combination of grouping two adjacent minterms are M0 M1, M2 M3, M0 M2, M1 M3. These are the possible combinations of grouping adjacent minterms. Then the number of cells in the three variable K map is 8. Since the number of variable is 3, there is only one possibility of grouping 8 adjacent minterms. The possible combination of grouping 4 adjacent minterms are M0, M1, M3, M2 and M4, M5, M7, M6 and M0, M1, M4, M5. These are the possible 4 grouping combinations. Then possible combination of grouping 2 adjacent minterms are M0, M1, M1, M3, M3, M2. These are the possible combinations of two grouping adjacent minterms. If x equal to 0, then 3 variable K map becomes 2 variable K map. This is the 3 variable K map. Here we are having one side as x and another side as yz. There we are yz having two variables and x having one variables. Then the number of cells in 4 variable K map is 16. Since the number of variable is 4. There is only one possibility of grouping 16 adjacent minterms. Let R1, R2, R3, R4 represent the minterms of first row, second row, third row, and fourth row respectively. Similarly, C1, C2, C3, C4 represent the minterms of the first, second, third, fourth column respectively. The possible combination of grouping 8 adjacent minterms are R1, R2, R2, R3, R3, R4, R4, R1, C1, C2, C2, C3, C3, C4, C4 and C1. If W equal to 0, then the 4 variable K map becomes 3 variable K map. The number of cells in 5 variable K map is 32 since the number of variable is 5. There is only one possibility of grouping 32 adjacent minterms. There are two possibility of grouping 16 adjacent minterms, that is grouping of minterms from M0 to M15 and M15 M16 to 31. If V equal to 0, then the 5 variable K map becomes 4 variable K map. Assessments include who introduced K-map, and K-map is an abstract form of dash diagram organized as a matrix of squares. It may be whether it is a Venn, cycle, block, or triangular diagram. There are cells in a dash number of cells in a four variable K-map. Summarize the rules of K-map, plot a four variable K-map, and explain the K-map using 2, 3, and 4 variables. These are the assessment you can access yourself. Thank you.